In this video, we'll be talking about properties of definite integrals. Press pause to copy these down in your notes. When you're ready to continue, press play. In this first one, we can see that the lower limit of integration is the same as the upper limit. So that would just make sense that the area of the region below the function is going to equal 0. On this one, if we wish to change the lower limit and the upper limit and reverse those, we can do that by just putting a negative out in front of the integral. On this one, we can split a region into two pieces. C is a point in between A and B, and so we find the region from A to C and add that to the region from C to B. On this property, we're just taking this constant k out in front of the integral. And then if we have the integral of a polynomial, we can split it up into separate integrals. This one just says that if f is a non-negative function, then the area, this is the area under the curve, has to be more than 0 or equal to 0. And then this one, this property says if f is less than g, in other words, if the graph of f is below the graph of g, then the area under the graph of f will be less than the area under the graph of g. Now let's apply these properties to some problems. The example that we'll be doing, evaluate each integral using the following values, and we're told that the integral from 2 to 4 of x cubed dx is equal to 60. The integral from 2 to 4 of x is equal to 6. The integral from 2 to 4 is equal to 2. Our first one, the integral from 2 to 2 of x cubed. Now the thing to notice on this is that the lower limit and the upper limit are the same, so that's just going to be 0. On this one, we have the integral from 2 to 4 of 15. This is the same as 15 times the integral from 2 to 4 dx. We're using the property that says we can take this constant out in front. And so that's just going to be 15 times 2. Since the integral from 2 to 4 dx is equal to 2, given to us in the property. In this one, we're going to split this up into two parts. And so we can write the integral from 2 to 4 of x cubed plus the integral from 2 to 4 of 4. We know that the integral of x cubed is 60, and then we know that we can take this 4 out in front of the integral, and then that integral we were given is equal to 2. So we have 60 from this one plus 4 times 2. So we get 68. Next example, we're told that the integral from 0 to 3 of f of x is equal to 4, and the integral from 3 to 6 of f of x is equal to -1. So to find the integral from 0 to 6 of f of x, we would just add these two together. So we would add the integral from 0 to 3 plus the integral from 3 to 6. So we're given that the integral from 0 to 3 is 4, and the integral from 3 to 6 is negative 1. So we add those together and we get 3. On this one, you'll notice that the lower limit and the upper limit are switched from what we're given. So this just means that we can negate the given value, and that'll be the negative of that. So the negative of negative 1 is equal to 1.